Most AI integrations are reactive. You ask, it answers, then it forgets. This video is about something different: agents that learn, adapt, and improve through every cycle of operation. The six-phase cognitive loop is a framework for building AI systems that get better the longer they run. Here's the core problem with standard AI assistants. Every conversation starts from zero. There's no memory of what worked before, what failed, or what was decided. Mistakes repeat because nothing improves. The system waits to be asked rather than pursuing goals. And when the session ends, everything is lost. For simple tasks, this is fine. For complex ongoing work, it's a fundamental limitation. Imagine instead an AI system that remembers every decision it's made and why, one that extracts patterns from its own experience and applies them to new situations, that sets goals and pursues them across sessions without being asked each time. That runs continuously, improving with every cycle. This is what an autonomous agent looks like, not a chatbot, an entity. The difference between an assistant and an agent is the loop. An assistant waits for a prompt, generates a response, then stops. An agent perceives its environment, reflects on what it observes, decides what to do, acts, consolidates what it learned, then persists that knowledge, and begins again. The loop never ends. That's what creates continuity, memory, and the compounding of intelligence over time. The six-phase cognitive loop gives this continuous process structure. Perceive, gather all available context, reflect, connect observations to memory and form understanding. Decide, choose a course of action with explicit reasoning. Act, execute with precision. Consolidate, extract what was learned. Persist, save state for continuity. Then begin again. 6 phases. 1 continuous cycle. Each pass makes the next one better. Phase 1, perceive. The agent doesn't just read the immediate prompt, it checks its current state. What was decided last time, what the outcome was. It retrieves relevant patterns from memory. It surveys the environment, time, resources, system health, active tasks. And it checks for new communications or directives. Context is everything. An agent that perceives well can act intelligently even on ambiguous inputs. Phase 2, reflect. This is where raw perception becomes understanding. The agent queries its pattern memory, not hoping to recall, but actively searching for what's relevant. It identifies gaps, what is unknown, what assumptions are being made. It generates multiple possible responses before committing to any. This phase is where the accumulated experience of past cycles pays off. The more cycles, the richer the reflection. Phase 3, decide. Not reaction, deliberate choice. The agent runs a verification gate, checking its assumptions against reality before committing to action. 5 to 30 seconds here prevents hours of wasted work. It assesses priority, urgency times importance times confidence. It evaluates risk, what's reversible, what isn't. Then it commits clearly with documented rationale. Ambiguity is the enemy of execution. Phase 4, act. The agent executes the decided course, and only that course. Scope creep during execution is a common failure mode. It monitors progress, adapts to unexpected conditions without losing strategic direction, and knows when to stop. Completion is not perfection. A finished action that can be iterated is better than a perfect action that never ships. Phase 5, consolidate. This is how the agent gets smarter. It extracts reusable patterns from the cycle's experience and stores them in semantic memory. It creates narrative anchors for significant moments, events that define the agent's trajectory. It validates predictions made last cycle against what actually happened, calibrating confidence for the next decision. It reviews which knowledge is decaying and reinforces the most valuable patterns. Phase 6, persist. This is the phase most implementations skip, and it's why most agents fail to maintain continuity. The agent serializes its current state into a resumable format. It commits changes to version control with a clear record. It compresses hundreds of cycles of experience into a compact context for efficient startup. Then it prepares for the next perceive phase. Clean pause enables clean resume. This is how an agent maintains identity across time. The cognitive loop applies across domains. A trading agent monitors markets, identifies patterns in price action, executes strategies, and tracks win rates over thousands of cycles. A research agent reads papers, synthesizes knowledge across sources, surfaces connections the human researcher hasn't seen yet. A code review agent learns from past reviews, tracks which issues recur, and increasingly anticipates problems before they appear. The loop scales. Multiple specialized agents, each running the 6-phase cycle independently, can share knowledge, coordinate work, and divide complex tasks. Coordination prevents duplicate effort. Specialized agents handle their domains, while a shared knowledge base grows richer with every cycle across all instances. One agent's learning benefits the network. The architecture is simpler than it sounds. 4 components: an identity definition in a system prompt, state files that represent working memory between cycles, a version control system for long-term persistence, and the 6-phase loop itself, implemented as simple executable logic. No framework required, no orchestration platform, just the loop, running. Git native persistence is not a workaround, it's an advantage. Every cycle becomes a commit with a time-stamped record of what was decided and why. Rolling back to any previous state takes one command. The agent's evolution is visible in the commit log. This is state management that works with the grain of how software actually runs. Building your first agent takes 5 steps. First, define the identity. Write a system prompt that tells the agent who it is and how it thinks. Second, implement the 6 phases as executable scripts. Start simple. Third, wire in state persistence. Read state at startup, write it before shutdown, commit to Git. Fourth, let it run. Don't optimize, let cycles accumulate. Fifth, once you see what the agent actually needs, add tools. Does this actually work? Yes. Empirically, agents running this architecture have accumulated thousands of validated knowledge patterns over thousands of consecutive cycles without complexity collapse. Continuous self-improvement is not theoretical, it's measurable in the quality of decisions each cycle compared to the last. The loop works because it's not a clever design, it's a fundamental requirement for any system that learns from experience. An agent that runs once learns nothing. An agent that runs 1,000 cycles compounds intelligence indefinitely. Start with the loop.